Yes, another moment to interact with grade 8 learners where we're going to discuss about this practical, that is paper 2 integrated science for your sake in the readiness for the open term 3 examination. So you have term 3 examination, those who are going to do complete papers. This is a right paper for you. This is a practical for grade 8 learners. So question 1, 20 marks. You are provided with to observe the provided setup. Answer the questions that follow. So there's a setup here with us. So this one is a simple circuit. So we have the parts. This part A is the dry cell or batteries. Part B, this is the switch. Part E with an A letter, that is ammeter. Then there is part C, this is light bulb, or we can call it lamp. V, that is voltmeter. So let's go. Identify the components labeled in the circuit diagram provided. Component C. Component C, where is it? That is a light bulb. So we're going to have light bulb or lamp. D, which one is it? D, that is voltmeter. So we're going to have voltmeter. Component E, component E. Component E, that is ammeter. Good. B, describe what happens to light bulb if the component B is closed. The component B, that is the switch. So what happens if it is closed? The bulb will go off. This is because why is the bulb going off? Why is the bulb going off? Now, we know that when this part is switched off, the switch will do what? When it goes off, when it is closed, the switch will provide, this is because the switch, the spelling of the switch, the switch, part B, will provide. So we know that when the component B, the switch is closed, it will provide a shorter path or short circuit. Are you getting that? So that the current, will bypass. So that is what happens. It will bypass the bulb. So that is what happens. The bulb will go off. This is because the switch, that is part B, will provide a shorter path, which is a short circuit, so that the current will bypass. So the current bypass the bulb. That is what happens. So we know that when you close this particular point, part B, that is where we have the switch. What will happen is that the bulb will go off. And when it is closed, the bulb goes off. And when the bulb goes off, it will provide a short circuit, that is a shorter path. So the current will bypass the bulb. Are you getting that? So the current won't come into contact with the bulb. And therefore, what happens? The bulb goes off. Name the form of energy that flows through the wires in this current. So the form of energy, we have electrical energy. That is the form of energy that is present or that is flowing through the wires, electrical energy. And we know that The energy provided by the dry cell here is electrical energy. It makes the bulb to light. Give two safety precautions. One must, remember, there are two forms of energy here. With battery, the energy stored in battery, energy stored in battery is called chemical energy. And the energy that flows in wires, so we call it current, electric current. That energy is referred to as electrical energy. I want learners to get the difference clearly. In this case, we are asked that the form of energy that flows through the wires in this current, in this circuit, sorry. So we know that energy stored within the battery here is what we are referring to as chemical. But once that energy has been transformed so that it can flow through the wires to the bulbs here, and so that the bulbs produces some light, that is called electrical energy. Are you getting the difference? So that is why I'm writing the answer as electrical energy. One safety precaution, two safety precautions. One must observe when dealing with electrical appliances at home. Now we know that the cooking gas, one of the precautions is that the cooking gas, in fact, let me not begin by that, because it is a precaution. So you say, do not leave the cooking gas or open gases, open flames unattended. So do not leave them. That is one precaution. Those cooking gases, or rather open flames, should not be left unattended. Another thing is that do not touch electrical appliances with wet hands. Are you getting that? So the third one, which I'm just adding for the sake of learners, is that do not overload the sockets. Do not overload the sockets. So that is what we need to not do. Observe the appliances shown below. So this is like an electric heater or electric kettle. Identify the common electrical appliance shown above. So we can name it electric kettle, or electrical kettle. What is the main energy transformation that occurs in this appliance when it is in use? So we know that what happens is that there must be electrical energy to heat energy, heat or thermal energy. That is the energy transformation. In this case, we're going to have electrical energy from electricity and then heat energy. You're provided with a small piece of wood. This is a non-metal, a copper wire, an iron nail. So we know that all these two, they are non-magnetic. And this one is magnetic. Even before I go to the questions, because according to what we have provided, we can easily tell copper wire is non-magnetic, but it's a good conductor of electricity. We need to know the difference. It is non-magnetic. An iron nail is a very good magnetic material. Which of these materials is a magnetic material? You see, as simple as that, an iron nail. Next question, state one property of a magnet. One property of a magnet, we know that magnets attracts magnetic materials. It attracts magnetic materials such as nails we've seen there up. Number 2 property, which I just want to add, magnets have 2 poles. They have 2 magnetic poles, e.g., north and south pole. Another property, which is the third one, which is just the same as this one. They attract and repel non-magnetic materials. This one is kind of an addition for number 1. Magnets attract magnetic materials such as nails as it repel non-magnetic materials such as wood and copper we've seen up there. And they have 2 poles. Those are the major 2 properties of magnets. Explain briefly how magnetism is applied in a common device like a refrigerator door. Now, we know that a refrigerator door, so I can begin by saying magnetic strip is around the refrigerator door. Sorry, it is around the refrigerator door. The magnet attracts the metal around the door, making the door to close tightly. Making the door to close tightly. So that is how we can easily explain for us to earn the 2 marks. So magnetic strip is one of the metal around, or one of the magnetic force of attraction around the refrigerator. The magnet attracts the metal surface. So I can say surface around the door, making the door to close tightly. Are you getting that? So that is why this magnetism is applied in a common device like a refrigerator. So you realize that the refrigerator door just closes itself and you cannot open it. It is tightly closed because of the magnetic strip located around that particular door. And the magnet now attracts the metal tightly around the door. So that is why it closes tightly. Draw a fire triangle and label its 3 components. So you're going to have a fire triangle that looks like this. Now, a fire triangle will always shows the 3 components of fire. That is oxygen, heat, and fuel. Those are the 3 components of fire. So this is how they are gonna look like. So you're going to have something of the sort. Remember, I don't have a ruler, that's why. And these diagrams should not be drawn by rulers. You should be drawing them just using bare hands, the way I've used mine. So there is a flame. It's going to be formed. So that is the flame. So in this case, we're going to have heat. We're going to have oxygen. And we're going to have fuel. So these are the 3 main components of fire. Oxygen sustains heat. Are you seeing that? It supports combustion. Supports combustion. Sorry, combustion is B. Combustion means burning. So that is the role of oxygen in this fire. Sustain heat and then supports burning fuel. This is now the combustible material. The material being burned, so the burning material. For those who may not know what combustible material is, this is the burning. So that is the fuel. And then heat now provides the temperature, provides the high temperature for burning. The high temperature provides the high temperature favorable for combustion. And even, in fact, we should not even begin from combustion. So it provides the high temperature for ignition and combustion. So for ignition, before that fire is seen, there must be ignition. That high temperature needed for ignition is provided by the heat and combustion. So those are the three major components of fire triangle, and we have labeled its three components: fuel, oxygen, and heat. 3 marks. No need of explaining. I'm just explaining for your sake. Give 2 common causes of fire in a domestic setting. So what can cause that? So we have faulty wiring. When there is faulty wiring. Number 2, what can cause fire is, let's talk about open flames or unattended cooking gas. So we have the open fuels or unattended cooking gases, faulty wiring. Those can be the 2 causes of domestic wiring. I mean, the causes of fire in domestic setting. Faulty wiring, or maybe we can talk about, damaged or exposed wires. So damaged or exposed wire, those can cause fire. So those are some of the common causes of fire in a domestic setting. Question 2, you are provided with 2 diagrams representing different states of matter. With diagrams, not 2, with diagrams. So this one, we know that the particles that are closely packed together and in a fixed position are known as solids. So this state is liquid, not solid. So we need to say just solid. That is a state. And then lastly, this is a gas state. Identify the state of matter represented by diagram A, solid. So I've said it is solid. Diagram C, gas. So gas state, solid state. Next question. Describe the characteristics of arrangement of particles in the state of matter shown in the diagram B. In liquid state, so we say that the particles, let's see, they are also closely packed, but not as compared to solids. Particles are closely packed, but not as compared to solids. They are not in a fixed position as compared to solids. They are able to flow from one point to another. So that is it. The particles are closely packed but are not but not as compared to solids. They are not in a fixed position as compared to solids. They are able to flow. That is the truth, that particles in liquids are able to flow and they are closely packed, but not compared to solids. Another thing we can say is the force of attraction. They are strongly held. They are strongly held by they are strongly held together, but not as in solids. So they are strongly held together, but not as in solids. Are you getting that? Name the process by which matter changes from liquid to gas. Now at boiling point, that is boiling. We can talk about boiling or vaporization or evaporation. Or you can say evaporation. Now is where now liquid changes to gas. So that is can be boiling, vaporization, or evaporation. Gas to liquid, condensation. Explain the term diffusion using an example of air freshener sprayed in a room. Somebody might ask herself, why is the teacher saying condensation, evaporation, and all that? So there's a formula here for you. She met Lily eating green colored lemon from Sudan. So this is a formula where she stands for solid, met stand for melting, Lily stand for liquid, eating stand for evaporation, green stand for gas, colored stand for condensation, lemon stand for liquid, from stand for freezing, Sudan stand for solid. So in the case where now solid to melting, evaporation, liquid to gas, evaporation. I mean solid to liquid melting, liquid to gas evaporation. And that is why we are saying liquid to gas can either be boiling at boiling point, remember, or vaporization or evaporation. Green, that is gas to liquid condensation. And in that case, we had gas to liquid condensation. I hope you now know. Now, because of space, I'll clear here so that I leave it for the next question. Let me erase here. That is good. So let's dive. Explain the term diffusion. So we first of all say diffusion is the movement of particles from their region of high concentration to their region of low concentration. Full stop. So that is what we are referring to as diffusion. So using an example of air freshener sprayed in a room. So we know that air freshener particles, when sprayed, moved from their region, spread, you can say spread out. So spread out from their region of high concentration to their region of low concentration in the room. of the room. Not of the room, but in the room, sorry, in the room. So they spread from their region of high concentration in the room to their region of low concentration in the room, spreading all over the room or covering. In fact, let me not repeat spreading, covering the entire room. Covering the entire room with the smell. Full stop, just like that, with the smell. Next, what is the SI unit for pressure, which is the last question. The SI unit for pressure is Pascal. Capital P, small a, or Newton per square meter, which is Newton per square meter. Are you getting that? So that is it, or it can be written as Newton per square meter. So that is what we are having as the SI unit of pressure. Pressure can be measured in Pascal or Newton per square meter. We know that 1 Pascal is equals to 1 Newton per square meter. So whether you get 10 Pascal, that is the same as 10 Newton per square meter. That marks the end of this practical paper. I love this paper so much. It was a very, very decent paper for a grade 8 learner. Kindly go through it, even including grade 9 learners who are preparing for KJSEA. You never know what might come. Maybe the question might be covering the simple circuit, or it might be covering that is form of energy there, or it might be covering magnetism, or it might be covering the fire triangle, or we have the particles of matter, or that is matter itself, or the question might be coming from pressure or force. You never know. So kindly go through this paper once again, and get the content, grab the content. That is what is left for you. Thank you for listening to Teacher Zamalek. Bye-bye for now. Let's meet in another paper.